Astronomers baffled by pulsing signal detected from star within our galaxy located 100 light years away in the constellation Ursa Major. Now let's deep dive into this AI podcast.
Okay, imagine this. A tiny flicker of light from a star way out there, 100 light years away. Then nothing. And then boom, 4.4 seconds later, the exact same flicker happens again. Scientists, well, they're pretty much stumped. And yeah, the idea that it might be something else. It's actually on the table.
It really does sound like something out of a movie, doesn't it? But this is real data, a real observation. And in this deep dive, which we put together just for you, we're going to get into the really fascinating details behind this study, this truly bizarre signal from space.
Exactly. We're looking at a new paper in Acta Astronautica. The scientist behind it is Richard Stanton from NASA, and he's pinpointed the source, HED 89389, that's a star up in Ursa Major. So our mission today is to really unpack this strange pulsing light, what we know, what scientists think, and maybe more importantly, what they don't know, which seems like quite a lot right now.
It certainly does.
Okay, so let's start at the beginning. When did they first even spot this cosmic puzzle?
Well, the very first detection was back on May 14th, 2023. And since then, they've actually seen this same unusual pulsing light 2 more times. So that brings the total up to 3 separate occasions now.
3 times. Okay, so definitely not a one-off equipment glitch or something. What's the signal actually like? You said pulsing light, but what makes it stand out so much?
What's really remarkable is how specific these pulses are. You get 2 of them, right? Back to back, very rapid. And they're not just similar, the study says they are, for all intents and purposes, identical. Same shape, same intensity. And the timing between them, exactly 4.4 seconds.
Exactly.
Precisely. And Stanton's paper makes it clear, signals that look like this, they just haven't popped up in any previous searches of the sky. It's unprecedented.
Okay, 2 super quick, identical pulses, 4.4 seconds apart.
That's
going to look weird. But I remember reading the star itself is acting a bit strange, too. It's not just the pulses.
That's right. The study highlights some, well, frankly, baffling behavior from the star, HD 89389. It seems to be fluctuating in brightness really rapidly. Imagine it sort of winking, almost vanishing for just a tiny fraction of a second, like a tenth of a second.
Vanishing, just momentarily disappearing. That's not normal stellar twinkling, is it?
Not at all.
But wasn't there something about how those flickers, the star's weird behavior, connects to the pulses? This is where it gets wild, right?
Absolutely. That's maybe the most mind-bending part. Stanton found this incredibly precise synchronization. If you look at the fine structure, basically the really detailed ups and downs in the star's light between the peaks of that first pulse. That exact pattern repeats almost perfectly in the second pulse, exactly 4.4 seconds later.
So the star is flickering in a complex way, and then 4.4 seconds later, it flickers in the exact same complex way.
That's what the data shows. And Stanton himself says quite directly, and this is a quote, "No one knows how to explain this behavior."
No one knows. Wow. That's quite a statement from a NASA scientist. It really makes you wonder. Okay, so the obvious question then. Could this just be something weird happening closer to home? You know, some atmospheric effect or an instrument issue they missed?
That's always the first place you look, ruling out the mundane. And they did. The study points out they've got over 1,500 hours of previous observations on this star, and nothing like these pulses ever showed up before.
Okay, so it's new.
Right. And they've also looked hard at whether some, moving object near the star could cause this. But the identical nature of the pulses, that precise 4.4 second gap, it just doesn't fit with a single object flying past.
Right, like an asteroid wouldn't cast the exact same shadow twice, 4.4 seconds apart.
Precisely. And crucially, Stanton is very clear. They've ruled out Earth-based interference, things like airplanes, satellites zipping by, even meteors or lightning, atmospheric disturbances, system noise in the telescope itself. They've checked all that, and these pulses look different. They are distinct signals.
Okay, so unique signal, check. Weirdly behaving star, check. Earthly stuff and nearby space junk ruled out, check.
But didn't the study also mention, wasn't there something similar seen before? Like a cosmic déjà vu?
Yes, and that adds another layer of intrigue. About 4 years before this detection, A very similar pair of light pulses was recorded from a completely different star, HD 217014. It's closer, about 50-odd light years away. Now, initially, that earlier signal was actually dismissed. They thought maybe birds had flown in front of the detector or something.
Birds, seriously?
Yeah, well, you have to consider everything. But later analysis showed, no, it wasn't birds. That explanation didn't hold up. So now you have two separate events, different stars, years apart, but showing this very similar, very strange double pulse signature. It suggests this might not be a total fluke.
Okay, that is interesting. Two different stars, years apart. It makes it harder to just wave away.
Yep.
So if it's not interference, not random space rocks, what natural explanations are still on the table, even if they don't quite fit perfectly? Stanton did explore a few possibilities, though. Like he said, none of them seem to be a slam dunk. One idea was maybe light getting bent, refracted by our own atmosphere in some really unusual way, maybe a shock wave passing through.
Okay.
Another thought was diffraction. Starlight being bent by some unknown object way out in our solar system, maybe in the Oort cloud, acting like a weird lens. They also considered partial eclipses, maybe by satellites again, or even really distant asteroids. And get this, they even thought about gravity waves potentially playing a role somehow.
Gravity waves. Causing distinct light pulses. How would that even work?
Well, the mechanism isn't clear at all. It was more like, exploring the very edges of known physics. But like the other ideas, it doesn't really explain the identical nature and the precise timing.
Right, like atmospheric bending usually smears things out, doesn't create sharp, identical copies.
Exactly. And that's the core issue. The uncertainty is huge. Stanton put it very plainly, saying, we don't know what kind of object could produce these pulses or how far away it is. And he added, we don't know if the two-pulse signal is produced by something passing between us and the star, or if it is generated by something that modulates the star's light without moving across the field.
So it could be something blocking the light or something actually making the star itself pulse like that. They just don't know.
That's the situation. It really highlights the mystery we're dealing with here.
And when you have that level of mystery, when the natural explanations aren't quite cutting it, well, you can't help but wonder about the other possibility, can you? The one hinted at in the study's title, alien origin not ruled out. How seriously does the research entertain that?
Stanton is very careful, very scientific about it. He's definitely not jumping to conclusions, but given how unique the pulses are, and because there isn't a good natural explanation right now, he does explicitly say, and this is another direct quote, until we learn more, we can't even say whether or not extraterrestrials are involved.
Can't even say whether or not, so he's not ruling it out.
He's not, which in scientific terms is significant. It means that possibility, however remote you might think it is, technically remains on the table simply because nothing else fits the facts yet.
That phrase definitely lingers.
Yeah.
Okay, let's talk about the scientist himself, Richard Stanton. It sounds like finding something like this wasn't just accidental for him.
No, not at all. Richard Stanton, though retired now, spent years focused on SETI, the search for extraterrestrial intelligence, specifically optical SETI.
Optical SETI, so looking for light signals, not radio waves.
Exactly. His whole approach, based out in Big Bear, California, was different. He used something called high time-resolution photon counting. Think of it like taking incredibly fast snapshots of the starlight, like thousands of measurements every single 100 microseconds.
Wow. Every 100 microseconds. That's unbelievably fast. What's the point of looking that quickly?
The idea is to catch really brief flashes of light, events that might last only milliseconds or less. Things a normal telescope exposure would just blur out or miss completely, like potentially laser pulses or some other kind of directed energy signal from an advanced technology.
A kind of cosmic Morse code, maybe?
That's one way to think about it, yeah. His method was tailor-made to find exactly these kinds of short, sharp signals, unlike traditional radio SETI, which listens for narrower bandwidth signals. And it's worth remembering his background, too. He worked on NASA's Voyager missions. He was an engineering manager for the Grace mission. This isn't some random amateur. He's got serious credentials.
Absolutely. Solid scientific background, innovative technique. It all lends weight to the discovery. It really puts this whole thing in a bigger perspective, doesn't it?
Yeah.
It's like a reminder that the universe is still full of genuine mysteries.
It is.
And the search for life, well, it takes many forms. This highlights how little we might still understand about even basic stellar physics, let alone potential alien technologies.
That's a great way to put it. This discovery, connecting it to the bigger picture, really underscores how much more there is to learn out there. It shows why we need to keep looking, keep developing new ways to observe the universe. Every unexplained signal like this one, well, it opens a door to possibilities we haven't even conceived of yet.
Right. So let's just quickly recap for everyone listening. We've got this really weird identical double pulse of light from a star, HD 89389, about 100 light years off. The star itself is acting strangely, kind of flickering in sync with these pulses. All the usual suspects, earthly interference, known space phenomena, they don't seem to explain it. Plus, there was that similar signal years ago from a totally different star.
That covers the key points. The unique signal fingerprint, the star's synchronized behavior, the ruling out of conventional explanations, and that previous similar event. It all adds up to a significant puzzle.
And while nobody's shouting aliens from the rooftops,
Definitely not.
the scientist who found it, using these very specific methods, admits that because we lack a good natural explanation, that possibility, well, it can't be dismissed yet.
Exactly. The core question just hangs there. What is this?
Is it some completely new type of natural event? Something exotic we haven't even thought of? Or could it be something artificial?
And the investigation is definitely not over. You can bet astronomers around the world are going to be pointing their instruments at HD 89389 now.
Which leaves us and you with a really big thought, doesn't it?
It does. If this or something like it did turn out to be definitively artificial, what would that actually mean? Think about it. What would confirmation of an extraterrestrial signal do to our science, our philosophy, just our whole understanding of our place in the universe? It's sparked by this one strange flicker, but the implications are truly massive.
What do you think could be causing these mysterious light pulses if not aliens? Comment it. Thanks.